What is OSPF route summarization? OSPF route summarization is a technique where multiple smaller subnets are grouped into a single larger subnet, called a summary route, when advertised to other areas or routers. Instead of announcing many individual routes, OSPF sends just one summarized route, reducing the number of entries in the routing table. Why is OSPF route summarization important? Reduces routing table size. Summarization groups multiple routes into one, significantly cutting down the number of routes each router has to manage. This leads to more efficient use of memory and processing power. Improves network stability. When a link fails within a summarized range, OSPF only needs to update the summary route, not every individual subnet. This limits the spread of updates and reduces unnecessary OSPF recalculations. LSA flooding speeds up convergence. With fewer routes and less LSA flooding, routers can converge, update their routing tables more quickly after a network change. Reduces CPU load. Fewer route advertisements mean the router has less work to do, lowering CPU usage and improving overall performance. Types of OSPF summarization. Inter-area summarization, area border router ABR, occurs between OSPF areas. The ABR summarizes routes from one area before advertising them to another area. External route summarization, autonomous system boundary router ASBR, happens when routes from outside OSPF, like from another routing protocol, are introduced into OSPF. The ASBR summarizes these external routes before announcing them into the OSPF domain. Example of OSPF summarization. Suppose you have these subnets in Area 1, 192.168.1.0/24. 192.168.2.0/24. 192.168.3.0/24. 192.168.4.0/24. You can summarize them into one route, 192.168.0.0/22. Instead of sending 4 separate routes to Area 0, the ABR will advertise only one summary route, reducing LSA flooding and keeping Area 0's routing table clean. Before proceeding with this video, ensure you have reviewed parts 1 through 4. In this lab, you will observe that Office 3 has 5 IP subnets. Our objective is to aggregate these subnets into a single route using OSPF route summarization. We know that Office 2 is the ABR, area border router. We will configure an OSPF area range on this ABR to summarize the subnets and advertise a single aggregated prefix to other areas. Let's check the IP address configuration on the Office 3 router, where you will see the 5 assigned IP prefixes. I now have both the Office 1 and Office 3 routers in front of me. Let's configure OSPF with the 5 IP prefixes. I'll demonstrate an alternative method by enabling OSPF directly on the interfaces instead of using the traditional network statements. This is just another approach you can use to configure OSPF, depending on your preference. Let's inspect the routing table on the Office 1 router. If you look closely, you will see that the 5 IP prefixes are now being learned and displayed in the routing table. Let's perform a ping test to the IP prefixes on Office 1 and verify if we can successfully reach them. As you can see, the routing table is growing larger. To simplify it, let's configure OSPF route summarization for the 5 IP prefixes, so they appear as a single aggregated prefix on Office 1's routing table. To do this, we need to configure the summary on the ABR, which in this case is Office 2, as it has both Area 0, backbone, and the other area. Navigate to the OSPF area range configuration and add the area that needs to be summarized. I just want to show you that you can use an OSPF summary calculator to help determine the appropriate network range and CIDR notation for summarizing your 5 IP prefixes. Let's input the 5 IP prefixes into the OSPF summary calculator. Now that we can see the summarized network address and CIDR, we can configure this summary on Office 2 by adding it to the OSPF area range. Let's apply the configuration and check the routing table on Office 1 to verify that only a single summarized prefix is now displayed for those 5 IP prefixes in OSPF. Great! Now, let's verify that we can still ping the gateways of the 5 IP prefixes to ensure everything is working correctly.